You can do this anytime until 10 o'clock tonight. And again, if you did so already, thank you very much. As previously, we're doing a live presentation tonight, as well as streaming it simultaneously. And we're still learning how to make this work, and hopefully every week we get the better and better at it. The talks, sorry. I should have shown this earlier. This is the slide about the Legacy Fund. We're about $1,000. Currently, we're heading for $2,000 as a goal, so everything helps. Thanks. So, as I mentioned, we're streaming the presentation tonight. All of the presentations are available on the NSC YouTube channel. This presentation should be up tomorrow night or later in the week, but all the previous presentations are up there as well. These talks are going to continue until about April 12th, because at that point the weather's getting better and everybody's more interested in getting out and getting their boats ready to go in the water. So it's about 51 days till launch day, and I'm sure we're all counting it down, as am I. There are two groups that make these talks happen. The first is a foreground group that recruits speakers and organizes the calendar and basically manages the beforehand stuff, and that's Tony Wright, Stephen Kidd, myself, and Park Davis. And then we're supported by a technical group who are at the back of the room, with Sean Batten, Ron Evans, Richard Kaland, Mark Rand, and Jason Zaire, and sometimes I'm in the back of the room as well. All of the speakers and organizers are volunteers, and we run on volunteers. So if you have stories to share, perhaps not this year, but next year, we'd certainly love to hear from you. So we're also hoping you can all attend next week's talk. It's Court Harkness of the Canadian Sail and Power Squadron, and they offer courses in boating knowledge that build from basic courses required by law up until what you need to cross the ocean. So just a reminder that we will have time for questions at the end of the presentation. For those in the room, use the microphone provided in the middle. And for those out in watching via YouTube, use the chat function, and we'll get those read out so that Eric can answer them. So tonight's speaker is Eric Fleury, again talking about boat electrical systems, which he talked about several weeks ago. There was so much interest and demand after that talk that we invited Eric back to go into a little bit more depth. So over to you, Eric.
My father's boat. Electronics originally, so having to fix some of the electrical wasn't too foreign to me, but I had really no expertise at that point. Eventually, I went to my current boat, which is an Ontario 32, which required extensive electrical work. It had some pretty, the kind of system you expect out of a 32-footer, so a proper AC system, fairly extensive 12-volt system. Most of it was completely wrong, as are many of our boats, unfortunately. So that led me to learning a lot. And actually, before I go any further, can you guys hear me well in the back, or should I go a little bit louder? Oh. out of the way before I trip, fall, and cause an injury. All right. So I got my Ontario 32, then started researching a bit more to be able to tackle the new challenges I had with it. Got fairly decent at it, and eventually people were starting to look and, oh, I like what you've done. I'd like if you could do that for me. So started doing some work on other people's boat, one thing leading to another. Apparently, I'm in the business now. So at that point, I decided to go take the full course and get a certification from ABYC, which are basically the people that are doing the industry standards for all marine things, not just electrical, but basically everything from surveyors to structure to engines, everything, and became certified about 2 years ago. And I've been doing proper electrical work as a certified marine electrician for those last 2 years. And they have a beautiful logo, as you can see. Now, what we're going to cover today, so it's basically a continuation of what we've seen last time. So we looked at wiring connectors, but we didn't have a time to really dig in a lot of detail, so we'll have a chance to review that. Using a main battery switch, which sounds very basic, but we'll review how it works and also how it works on the back end. Fuses, which is a very important topic. A lithium conversion step. So last time we talked about, what are the benefits of lithium? What are the costs? Is it really more expensive? Sometimes it's not. Sometimes it's the cheapest form of battery. So we'll look at it basically if someone decided lithium is for them, and obviously it's not for everybody, but the people that it is the right choice for them, how to go about doing the conversion, because those are not drop-ins, despite a lot of the ads saying they are. How to install a battery monitor. So we talked about the benefits of a battery monitor, but we didn't talk about how to install it, so that's something we'll cover today. Solar, and more solar. So we talked about solar. What we're going to do is we're going to dig deeper in terms of really how to design, how to install a solar system. Q&A and hands-on, time permitting. So I brought a bunch of gadgets and goodies. So time permitting, we'll have the time to take a look at that. And if not, then we'll just do a quick wrap-up after for the ones that are interested or curious. Now, wiring. So that's something we had looked at last time, but we had raced through pretty quickly. So we'll have a time to take a better look this time. So basically, the wire types, you got household wire, you got automotive wire, and you got marine wire. So the household wire is a big no-no. It's also very commonly used on AC systems on boats. Half of your boats that have AC system will have household wire. I recommend ripping that thing out as soon as you can. The main problem is that it is single strand wire, which means that it will not withstand vibration, it will break, which will lead to a bad contact, which will lead to potentially heat, potentially a fire. Fires are bad, obviously, especially on a boat. And they're very frequently used. Now, automotive wire is better, it's not the best. That is actually what a lot of our boats have on them. The older boats, they didn't have the marine wire we have today. So automotive wouldn't be my go-to, but if you see it on your boats, it's not the end of the world. The difference between automotive and marine wire, they are both multi-strand, so they will not break from vibration. Obviously, they're meant to be used on vehicles for both of them. The difference is you will have more strands on the marine wire, and also it will be tin coated to provide additional resistance for corrosion. So if you are going to do any work, you want to use the marine wire. A bit more expensive, but it's totally worth it because it will last a very, very long time. Back to the automotive wire, a lot of us have boats that are probably 40, maybe even 50 years old. The old plain copper wire, if the boat has not been in salt water, is usually just fine. If the boat has been in salt water, you can usually tell. Usually when I go on a boat, if it has been on salt water, I can tell within seconds. That said, as long as it's in good condition, you're not problems, that is absolutely fine. Now, in terms of the wire gauges, when it comes to AC systems, that's pretty straightforward. Obviously, we do not want to use household wire, ever. But the gauges of wire are the same. We just have to make sure we use marine wire, but it is the same wire gauge. So we have it here. You don't even have to remember any of that stuff. It is the same as household. Now, 12 volts, that's where it gets a little trickier. And that's what actually gets very, very tricky. Because it's not just about the ampacity of the wire, it is also the length of the wire. So AC systems, if you're doing 15 amp circuits, which is the same as a household circuit, you know you're going to use 14 gauge. No mystery. That's it. 14 gauge. End of story. Now, when it comes to 12 volts, you will have voltage drop over distance. So depending on the ampacity needed to be carried and the distance, you will have to choose different wire gauges, sometimes extremely, extremely big wire gauge. For example, inverters basically, they will take the voltage from our batteries and transform it into 120 volts for where regular appliances can be used. Oh, hold on. These will usually require 2-aught wire. That's about the size of a finger. Those are really, really big wires. Now, lighting circuits can be as low as maybe 18 gauge. So it really depends. And I'm going to show you a graph that's going to blow you away if you haven't already seen these. That is a graph that tells you what kind of gauge you have to use based on the distance and the ampacity needed to be carried. So what that means, obviously you're not going to remember any of that. I don't remember any of that. But what you can do is you can use reference tools that will tell you, basically figure out what your length is, make sure to count both ways, your positive and your ground. Is there like an evil, oh, okay, never mind. I was wondering if our microphone was haunted or something. So you need to, usually it's going to be double your length because you have your positive and you have your ground. So 16 to 14. So even if you forget that the blue one is 16 to 14, it says right on it. All of them will always say right on it. And obviously you got the yellows, or actually I can pass those as well, but who's going to catch? If you want to pass it around.
Did you guess at the yellow?
Huh?
Did you guess it?
They're all gray. No, I'm kidding. Actually, colorblind people see colors fairly well. It's just we can't, instead of seeing like 25 millions, we might see a few thousands. But we do see colors. Most of us. When you do your crimp, it's very important that you do a pull test. And what that means is that you have to try to pull on it and see if it's going to hold or not. Because if it doesn't hold, it's going to fail at some point and you will have a problem, especially if it's a live wire and it falls on something like, I don't know, an engine, which is grounded, or a lot of the metal parts on the boat, which are grounded. And you want to make sure if you have spade connectors, basically that would be, do I have spade connectors? I don't have spade connectors. These would be these right here that insert into one another. You can have them male, you can have them female. Whichever one it is, you have to make sure it's a tight fit so it doesn't fall off. If it's a little bit loose, not the end of the world, just a pair of pliers, give them a little, a little squeeze, make sure it's a tight fit. And they will usually, after a while on our boats, it's not uncommon to have one or two that have worked themselves loose a bit. Yes?
Usually you find those on your electrical panel.
Yes, your panel, especially if you have an older panel, the newer panel.
On it on your panel. I was told to go to the mic.
All right, so the question was, usually you'll find those on your panel. Yes. Older panels specifically that have fuses, usually you will have those connecting to your panel. The newer panels, the Blue Sea panels are breakers, they're screws, but the older ones will be like that. So that's basically the do's. The don'ts, we want to make sure not to use marrettes. Ever use marrettes on boats. They're not meant for multi-strand wire, and also they can come loose with vibration. If you see marrettes, that's a sign that you need to look a little deeper and see what else has been done. If you see marrettes on 120 volt systems, that could be household wire hiding in there, and that's going to be very easy to tell. You're just going to have to twist it off, and you'll see right away. Another quick way to tell if it's household wire or not, just feel it. Household wire is single strand. It's, who here has actually seen firsthand and felt household wire? Just raising your hands. It's pretty stiff, right? It's copper, and it feels like copper. Marine wire is very much like spaghettis, actually. This one is smaller gauge. It's 18 gauge, but you can pass it around. It feels very flexible. So usually when I go on boats, the wires are often very dirty. The writing on them sometimes is you can't read it anymore. Just reach in and you'll see right away if it's household wire, if it's proper marine wire. We also want to make sure not to wrap wires around studs ever. We can do that with household wire, but we can't do that with marine wire because the multiple strands won't hold properly with a nut. They need to have a connector. We also don't want to use soldered connection. A lot of our boats back in the day, they were using soldered connection. If you have them, it's not the end of the world, but you want to make sure you don't do any work that way. You want to make sure that you use the crimp connectors, or anybody that you get to do work for you uses the crimp connectors. Also, we don't want to use more than 4 ring connectors on the same stud. So let's say, for example, on your battery terminal, if you have 6 connectors, that's too many. One quick note also regarding those little ones that I brought here, and those one I brought them here for a specific reason, because I don't mind us using them. When I started, I didn't know exactly what I was doing. They just look convenient. They are. Because if you have a GFCI, who here has installed a GFCI, whether at home, on the boat? Some of us. You can't take the screws out. Well, you can, but good luck putting them back in. I've learned that one. So you can't take them out, so you need those. But those are not marine rated. They look like they are. They got the nice shrink wrap and all that, but they're not. The one you need to use for marine, they look just like that, but they call them captive forks. They got a little lip. So the reason for that is that this one is held only by pressure. There's nothing mechanically holding it. If your screw, for any reason, becomes loose, even the slightest, plump, comes right off. Would thing has ever come loose on a boat? Nah, that never happens. So that's why these, no good. You need the ones that have the little forks at the end, which are what we call the captive forks. The good news is we got a ton to play with because I can use them. So in recap, barrettes and household wire, those will be your 2 nemesis. If you see them, address them right away. A lot of the stuff is like, that's how they did it back in the day. But these 2 things you'll want to address immediately. Also, with the understanding that there's no shore power at the docks, if you see that your AC system is all done using household wire, don't be afraid to pull all of that stuff. You don't need to be a rocket scientist. Just make sure you pull the right thing, pull all of that stuff off, and you'll have done an upgrade right there. Any questions on the wiring and the connectors before we move forward? Yeah? You, sir, are learning faster than I am.
Well, I've been resting. You said don't use solder at all. And why is that?
The reason, well, there's a few reasons. We want to use these, which do not require solder. Also, if a piece of wire is soldered, then that multi-strand piece of wire just became single strand. And that could be a point where it could break. So that's the main reason for not wanting to use solder, is because, well, first the standard has been defined on using the crimp connectors, and also whichever part is soldered is now officially a solid strand. I think I can kind of see where you're going with the question, because sometimes we will have situations where we don't want to have a multi-strand wire. It's going to have to go under a screw, and you can't really use that very well. We're not talking about wrapping it around a stud or something. We're talking about, let's say, for example, some kind of charger or solar controller or something like that. If you have something that presses down on your wire, then what you can do, I don't have any here, but they're called ferrules, and they're basically, I could show you later on. It's a special crimper, it's a special connector that you can use for that.
Thank you.
Which basically turn a multi-strand in kind of a block, but without really making it a single strand. Which is a bit more advanced and not as common. So moving on, battery switches. So what I really want to talk about is the two main types. You got basically on-off switches, and you got your 1-2 all or 1-2 1+2. The type that you're going to have on most boats is going to be one of those three. Different manufacturers, exact same thing. They're all identical. Usually, you're going to have a house bank and a bank which is more for your start. Now, Mark, right, had mentioned a very interesting point. Some people will have two banks, and the two banks can be used equally, which if you're using a switch like that, that's perfect. Because basically, your two banks are not really start or house. They're whatever you selected is going to feed everything. And obviously, you got an option which is either called all or 1+2, which basically parallels both banks together. Now, to that point, neither bank is truly start or house. If you choose one, whichever bank is connected to one, it can be start, it can be house, is going to feed everything. If you choose two, whatever is connected to two is going to feed absolutely everything. Now, if you're using a lithium house bank, that is a really bad idea. Your alternator will not enjoy trying to charge your lithium bank. Your lithium bank can kill your alternator in many, many ways. Also, it's the wrong charging profile. Your alternator is set up to charge lead acid, not lithium. And also, your batteries won't like starting your engine either, your lithium batteries. So what it looks like like on the back is basically what we just described, and I find it very interesting to take a look at it because it basically explains everything. You got two inputs, two banks, but you only got one output. So if you choose one, well, everything is from one. If you choose two, everything is from two. So the cons. So it requires micromanagement by the user. So let's say I want to start my engine and one is my start. I got to put it to one, start the engine. If I want to charge my house, then I got to put it to two or all or 1+2. If I want to charge both batteries, the moment I shut off my engine, I have to put it back to two only because if I leave it at one, I could deplete my starting battery, and if I leave it to all and I deplete something, well, I've depleted everything, and I'm going to learn the joys of sailing off the anchor. I've done that. It's interesting. Your battery banks are not dedicated. You can deplete one or the other unknowingly, or both. And to make things even more interesting, if at any point in time, when you go from 1 to 2 to all to 1 to 2 to all, you actually go by off, you've just killed your alternator. If you do that while the engine is running, obviously. And as mentioned, you have the risk of damaging both batteries and the alternator if you use it with lithium. So these are fine with lead acid if you don't mind a little bit of extra management, but they do not work well at all with lithium. Hint, it's one of the steps of lithium conversion, we'll see later. The alternative is an on-off switch. The main difference of the on-off switch is how many outputs do we have on this one? 2. So they are 2 outputs. So your input 1 has output 1. Input 2 has output 2. So at all times, your starting battery goes to your engine and nothing else. At all times, your house battery goes to your house loads and nothing else. Also a lot easier to manage because if I want to, let's say I get to the boat, I want to have lighting, what do I have to do? Put it on. Well, what if I want to start my engine? Just start it. Cool. What if I stop my engine? What if it's night and I have to turn on my anchor light? All right, now, if your starting battery is connecting to your engine, it's your engine only, the problem that that brings is, well, what about charging the house battery from the alternator? Assuming you don't have lithium, because if you have lithium, that's a different discussion. But if all your batteries are lead acid, but you chose to have an on-off for the simplicity, very likely you will still want to charge your house battery with your alternator. Not necessarily, but very likely. In my case, I now have lithium, but even before I did, I had an on-off switch, and I had nothing to charge my house from my alternator. And a very, very small and low-power alternator. It was just not worth it for me, so I just let it be. But for most people, they're going to have a diesel engine with a decent alternator, and it will be worth it to try to charge the house from the alternator. So you have those 2 types of devices that come in very, very handy. They will allow you to charge both banks automatically. No switching, no messing, nothing. So the first one is the battery combiner. So what it does, it parallels the banks when there's a charge present, and only when there's a charging voltage present. So basically, it's the equivalent of having someone right by your switch. The moment that there is a charging voltage, it puts it to all automatically. Charging voltage is gone, everything stays separate. But the moment that you have a charging voltage, it puts the banks together, to charge together. That's one way to do it. Another way to do it is what's called a battery isolator. That does not parallel your banks. As you know, obviously a combiner combines. An isolator keeps things isolated. So what it does is that it will share the charging voltage with both banks without actually paralleling them. All right, so mine is kaput, right? Oh. So I'll have to try not to move around too much and speak in that general direction. Any question on the battery switches so far? All right, moving on. Fuses. By the way, the fuse block you see right there, I highly, highly recommend them. I install them on almost every boat I work on. They're amazing. Your boats are probably filled with all those inline fuse holders all over the place. When you have a problem, you have to chase them down to try to find them. A real nightmare usually. This makes it a lot simpler because you have all your fuses in one easy spot. More on that later. So where do we need to put fuses? So all house loads must be fused, including at the battery itself. And that's something that most of your boats will not have. Most of your boats will not have a fuse directly at the battery because when our boats were made, that was not a requirement. That said, it's a good idea to add them. And it's, the good news is that it's very, very easy to add them. We'll see how to do that. Each circuit also must be fused. An example would be the fuse box we just saw, or a panel, either fuse or breakers. Now, some devices, for example, bilge pump, will also require a specific fuse rating beyond what's just required to protect the wire, and we'll take a look at that a bit later on. The engine battery does not require a fuse as per ABYC standards. So what that means is that you don't need to put a fuse on the battery that is used to start the engine. I still think it's a very good idea to put a fuse. Now, the good news is that because we're not required to put a fuse, we can put one which is grossly oversized, which is the only place we want to put a grossly oversized fuse. The reason for that is if you're starting your engine, you don't care if your wire overheats a little bit. You want your engine to start. You don't want your fuse to blow and then have to run around to find a fuse. You want that thing to start, because chances are you might need it to start, and it might be very important for it to start right now. So if you do put one on your starting battery, and I recommend you do, and keep in mind also that a lot of us don't really have a starting in a house battery anyway. With the 1-2 switches, it is whatever it is. So with that in mind, a good idea to put one on the starting battery, but make sure to oversize it, which is the only time I'll ever suggest oversize a fuse, but do oversize it, and do oversize it generously. So if you figure that your starter might draw, 50 amps, fuse it for at least 100. The only thing you want to avoid is what we call a dead short, where you have basically a big cable that's positive touching something which is grounded. Other than that, you don't really care. If for any reason your starter is drawing a bit too much, you don't care. If it stays stuck and it keeps drawing, let's turn the thing off. Now, battery fuses, there's different ways to put fuses on batteries. The easiest, assuming you don't have lithium, are those. They're called marine-rated battery fuses. They are amazing. They require no modification to your boat whatsoever. All you need is to put them on, and they're not even expensive. There's basically two parts. There's the fuse holder, which is the bottom part right here. Then you got the little fuse right there. It goes right on your battery terminal, and whatever wires were on your battery terminal go right on here. So super easy to install. You don't need to be an expert, and I recommend everybody to install them. If you want to make me real happy, that would be the homework. Check to see if you have a fuse on your battery and put one of those. They're not expensive. Between the fuse holder and the fuse, it's not even $100. Now that's if you don't use lithium. If you use lithium, you're not that lucky. You will need what we call a Class T fuse, which is a lot bigger, doesn't go straight on your battery. The fuse holder is more expensive. The fuse is more expensive. The reason for that is, I'm going to get a little nerdy there, so for those that are interested, that's fine. For those that only understand half of it, that is still fine. Lithium is able to put out a lot of power at once, insane amount of power at once. And the Class T fuses are rated to withstand up to 20,000 amps without welding themselves shut. So what that means is that if you, let's say for example, we have a marine rated battery fuse and a Class T fuse, both rated for 250 amps, because they will have similar amperage rating. You can get them in 100, you can get them 200, 250, 300 something. Let's say 250 for argument's sake, both of them. If they're subjected to 1,000 amps, they will blow, both of them. If they're subjected to 2,000 amps, they will blow, both of them. If they're subjected to 10,000 amps, the class T will blow, end of story. Now, the marine rated battery fuse is not rated for that. There is a chance, not a guarantee, but the chance, a possibility that it will melt and become a solid connection, and it's no longer a fuse. It's just welded itself shut. And it's no longer fusing anything. It's like if it wasn't there. So if you use, so with that bit of nerd stuff aside and the 20,000 amps and all that, if you use lithium or have some kind of humongous battery bank, which with the size of boats we have, is not going to happen unless we have lithium, you want to make sure you get a class T fuse. Also, inverters, often the manufacturers will specify using a class T fuse, though I did take the time to contact one manufacturer and they confirmed that a marine rated battery fuse would do just fine. And I did actually myself use a marine rated battery fuse for an inverter in the past. That said, do follow manufacturer's recommendations, but doesn't hurt sometimes to check with them. Now, I did a little, well, not really a graph, a little table there to compare the different types of fuses to try to make some sense out of all that's out there. So basically, you got your high amperage type of fuses. You got your class T, you got your marine rated battery fuse. Class T, if the manufacturer specifies, or if you have lithium. If not, the marine rated battery fuse is super easy to use. The problem with the class T is you need to find a place to mount it, and very likely you need to replace your cables and make new cables because things don't reach where they used to. So those are basically for high ampacity, which basically translates to at the battery. Now you got other types of fuse. One that I like is the A&L fuse. I like them because they're cheap. Who doesn't like what's cheap? So these are more for medium current. They're not for crazy high current. In my case, what I do for my house loads is I have a class T right off the battery, then going to an A&L fuse. Do I absolutely need to have two? No. I could go with a smaller class T rated directly for my house loads. But what I've done is I've gotten the same size of class T as my inverter to have less spares and less complication, and have an A&L right after. And the reason for that is that little A&L cannot handle a lithium battery. But as long as you got the proper class T first, you can put all the world's cheap fuses, because if there's something in the realm of 10,000, 20,000 amps, your class T is going to blow, everything's going to be fine. Anything more run-of-the-mill, these are going to do the job. What is that? Huh? Oh, I like to go up there and kind of do my, but yeah, that's coming in. Yeah. They're trying to keep me leashed to that podium. Basically, it's a very nice way of saying, stop moving around. We can't hear you online, which is very nice, by the way. Now, when it comes to your your smaller circuits that have less amperage, basically those are just your circuits themselves. Could be a bilge pump, could be lights, could be whatever, fridge. They're just as good from an electrical perspective, but I hate the glass fuses. I hate them with a passion. And if you had to use them, you probably hate them too. Fuses will blow when they have to. It's a weak link put in the system to make sure that your wires don't burn. So there's something that can blow and burn safely. They both do that. The problem with the glass fuses is they like to break, which is very annoying, especially when you have a spaghetti of wires everywhere with random fuses at different places that you don't exactly know where they are, and it's a new boat, and for the first 5 years, you're still chasing fuses. I'm not a huge fan of them. They work great. If there's some that I have on my boat that I haven't replaced yet, because, you know, I could replace and put one of those, but I can just put another one of these and go sailing or have a beer, so we all know what I'm going to do. But if you are to install a new fuse holder, you're probably better off going with the blade fuses. They don't really tend to break, as the glass fuses, they break all the time. They're annoying. Also, another option, you got breakers, which are basically the same thing. You're going to have some that are, oh, I have to remind myself not to run away from the mic. So you're going to have some that are bulkhead mounted. Usually those are higher power, which you don't necessarily want on your main panel. This one, for example, is a 60 amp. Your panel might be rated for, I don't know, 100 amps. So you might or might not, it might or might not work out very well. Let's just put it down. You might just have it separate for, let's say, for example, like a windlass or something like that. You have your regular breakers that are panel mounted. And again, they work just as well. Usually for always on circuits, I will use the blade fuses, because I don't need a breaker, it's an always on circuit. Why would I bother? They're cheap, they work. And you can put them out of the way. Always on circuit, you don't need to see whether it's on or not. Of course it's on. And these I keep for just for basically panel. Now fuse sizing. There's really two items and sometimes a third one. So there's wire length, wire gauge, and also sometimes the device itself. For example, bilge pumps. Let's say, for example, that you have a circuit where you have, let's say your wire can handle 10 amps. You could put a 10 amp fuse or breaker and you will protect the wire. What can happen though with bilge pumps, and maybe with some other devices, but specifically bilge pumps, is the motor can get basically stuck and just keep trying to spin and overheat, which is not a short. It will never draw more than the rating, which is 6 amps, but it will draw it continuously to the point that it could burn and start a fire. So in that case, your wire is not going to burn, your bilge pump will. So if you have any device that specifies a fuse, even if the wire that's connecting to it can handle double, triple that, you want to go with that exact specific manufacturer's recommendation, because the device itself could start a fire. And also, every device will end up protected by multiple fuses along the way. Basically, each time you go to a smaller wire, you will change fuse size. So a quick example here that I have based on my own boat. So I have my lithium batteries. I have a Class T, and it needs to be a Class T because it's lithium. Then I have an A&L fuse, which is cheap and easily replaceable. And also that Class T there, which is super expensive, never going to have to change it because it's never going to blow. Unless there's a dead short of like 20,000 amps, which would be real bad. And at that point, I won't have any problem with replacing it. I'll be quite happy that it blew. But really, if I have any kind of normal overcurrent, this one is going to blow, and it's going to cost me probably about $8 to $10 to replace. So I don't mind putting a big one there. And then that goes to your circuit. So basically, often what it's going to do is that it's going to go to very likely a fuse box for your always-on circuits, and a panel, which either fuses or breakers for anything which is switched, basically. Any question on what we've seen there? There was a ton of questions last time. You guys are, oh. I'm being told I'm halfway there. So lithium conversion steps. So hopefully you guys appreciate my sense of humor and very poor photoshopping skills. So you've adopted a lithium battery. You're ready to bring it home. What do you need to be ready for it? What do you need to make sure it's comfortable and has a happy, long life? So your battery cables probably need to be replaced for a few reasons. Don't forget, you're going to have to add a Class T somewhere in there. So your connections might not be at the same spot. Your posts on the battery itself might not be where the old battery was. You might need a heavier gauge of wire. And the posts themselves might be a different size. So expect to have to change basically every piece of wire from the battery to the switch, including the switch. Your switch should be replaced by an on-off. It will work with a 1-2 all. It's a really bad idea. Don't do it. Your batteries are not going to like you. Your alternator's not going to like you. Something is going to go wrong at some point. Your fuses will need to be replaced or installed. As we know, most of the time, there's no fuse directly at the battery. Back when our boats were made, that wasn't a thing. You're going to have issues with the alternator. Guarantee you, nobody here has an alternator that can charge lithium. You might have some trouble with your shore power, which again doesn't really apply here because we don't have shore power. But for those that do, that can be a problem. Basically, the charger might or might not have a profile for lithium. So, kind of digging in a bit more detail. So, in terms of battery cables and fuses, we might have, depending on, again, just an example, we might have to go with larger wire, maybe up to 2/0, depending. Again, depending on the size of fuse we use. And there will have to be a Class T fuse, and these are not cheap. Between the fuse and the fuse holder, they're about, I think, 150 each. So not a cheap thing. Main battery switch, you will want to replace and put an on-off. Your shore power charger might or might not be compatible with lithium. If it's recent, it probably is. But check with your, it might say on it, or check in your instructions or with the manufacturer if you need to find out. An alternator, it just isn't compatible. That one's not going to work. If you go lithium, your alternator will charge, and again, as part of having an on-off switch, your alternator will be dedicated to your starting battery. Fear not, there's a solution. So, as we said, stock alternators will not charge your lithium battery. Don't try it, it's a real bad idea. The batteries will suffer, the alternator will suffer, and it's just a matter of which one you kill first. So, the easiest solution is to use a DC to DC charger. What is a DC to DC charger? Well, you know, we've all seen an AC to DC charger, right? Shore power. This is the exact same thing. Instead, your starting voltage, instead of being 120 volts AC, is 12 volts DC. And how they work is very straightforward. When it senses a charging current on your starting battery, because we don't want to just take what's on the start and dump it on the house, that kind of defeats the purpose. We only want to take a charge if there's a charge coming in. So when there's a charge coming in, it will activate and use part of that power, part of that voltage, to charge the lithium. Now, this is not like a battery combiner or a battery isolator. It is actually closer to a solar controller in terms of what it does. It will see what the battery needs and give it exactly what it needs, just enough, no more. You might decide that, you know, for example, in my case, gasoline engine, price of gas very high. My engine likes to drink gas, a lot of it, and my alternator is tiny. So for me, it's just not worth it. I'm just using and I don't motor all that much. So I'm just using the alternator to charge a start battery and nothing else. And I use solar to charge the house. If you have a large solar array, you might or might not care. Actually, a lot of customers that I've had that did the lithium upgrade, I said, you don't necessarily need to install one of those. If you want, we can install one, and I've yet to have one saying, yeah, I'd really like to install one. With just solar, it works. And truth be told, we usually don't use our engines all that much here. I mean, what's the furthest we're gonna go more? And usually we're probably not gonna motor all the way to more. If there's no wind, we're probably, and even then, that's what, like 3 or 4 hours? Doesn't make a very, very big difference most of the time. Any question on the lithium conversion steps? All right, on to battery monitors. These things are awesome. I recommend yes. Yeah, you'll want to go to the microphone, or else they'll tell you to go to the microphone, so I'm telling you ahead of time.
Are you going to be speaking later about why you would want to convert to lithium?
We kind of covered that last time, unfortunately,
Okay,
because it's awesome. We kind of covered last time. I have no problem with if we have enough time, maybe we can cover at the end, or I have no problem with having a side discussion with you later on if you have questions on that. Yes. What time is it right now? got to get going. Battery monitors. So these are awesome. I recommend them. I was going to say I recommend them to everybody, but that's not true. Some people don't need them. If you have the most basic of basic systems where you're basically just running your instruments, you don't care what state your battery is in, honestly. You know it's going to be fully charged. You have nothing that can really deplete it. If your battery is dead, you replace it. If your battery is properly working, you use it. But if you have a fridge, or if you have an inverter, or you have a lot of lighting, or if you have any kind of, basically, if you have more than one battery on your house, you probably want to install one. The things it can do for you: it can display real-time incoming and outgoing energy, either in amps, watts, or either, but really boils down to the same thing. It can display voltage of your battery. But the one which is very, very interesting is the battery capacity. So what these do is that it will monitor the amount of electricity coming in and out of the battery, and they'll be able to tell you, we got 50% of battery capacity left. We got 40% of battery capacity left. We got 80% of battery capacity left. That will allow you to better manage your power. And they're not expensive. So some of them, actually most of them have a screen. Some of them are just Bluetooth, for those that prefer that. There's basically two parts, and it's very straightforward. You got your screen, which really doesn't do a whole lot, and you got the shunt, which is really the important part. Some of them have only a shunt. Those are the models that are Bluetooth only. I don't know about you guys. I love Bluetooth. I love electronics, but I like to have my panel, and I like to have my panel tell me what's going on. If I'm on my boat, I don't want to have to fumble from my phone, go through my apps to see what's going on. I want to look at the panel, switch on, switch off, see what's happening. But again, different people might have different views. So the shunt actually connects on the ground side of the battery, and that's what is the brain. That's what calculates everything that goes in and out both ways most of the time, although we'll see in details not necessarily. But if you have a good one, it will track everything coming in and out and be able to tell you exactly how much power is coming in, coming out, and most importantly, use that to tell you how much, basically it's like a fuel gauge for your battery. Pretty useful. Imagine going out there with no fuel gauge. And you can't just dump a stick in there or knock on it or anything. You're just going to have to go on faith alone, leave the dock, and I hope I'm good. I hope I get to come back. That would be a very frustrating weekend experience. So how to wire it? So I took an example straight off Amazon. It's basically for this one here. We're going to see the different models. That's the one I have. Works great, super cheap. So the steps are very straightforward, but you want to make sure you get them right. This is your main ground with everything going through it. Get it wrong, you could have a fire. So it's basic, but it has to be done right. So you have to disconnect the wire that's the battery ground. So basically, right here, the main wire or main wires with an S that goes to your battery negative will go to the P minus right here. So basically on one side of the shunt. Don't reverse them. It's going to tell you're charging when you're discharging and discharging when you're charging. I did that once. It gets interesting. We learn from our mistakes.
That was on your boat?
Actually, no. I wasn't certified then, so that's my excuse. Again, it's not, that's not one of those problematic things, but it's one of those embarrassing things. Because these things, if you get a good one, they will work both ways. The only thing is if you reverse them, then, you know, you'll get an incorrect reading of what's coming in and coming out. So you want to do that. Then you want to run a wire from the, here it's shown as the B minus, to the battery minus, battery negative, ground. You don't mess with your positive feed at all. Leave it. The only thing you will do is a small wire Doesn't have to be large gauge. 18 gauge is fine. This one is duplex. You got a positive and a ground. You're not going to use the ground. You're only going to use the positive. Why? Well, you already got it. So all you got to do is run a very likely fairly small wire to it to power it. That will power the shunt, and that will power the display interface, which has a cable that comes with it. So basically, all you got to do is disconnect. Let's say you just, easy example, let's say you only have one main wire that goes to your battery negative. Take it from here, put it here, run a wire from here to here, making sure to use a heavy gauge wire. That wire has to be the same gauge as this one, hoping this one is the right gauge to start with. Run a small wire from the battery positive just to power it. Don't forget the fuse. Connect the screen, and off you go. Now, the only pitfalls to watch for, remember to put a fuse on your positive. And don't rely on the fuse that is directly on the battery. The fuse directly in your battery is probably something like 50 amps, 100 amps, which is feeding your panel with a fairly large wire, with a large wire gauge. You're not going to use a very large wire gauge here, so you'll need another smaller fuse, probably half an amp or something like that. And you want to make sure you use a properly sized wire right here to connect from the B minus to the battery negative. That's it. You now have a properly functioning battery monitor. Now, it's not a full buying list. It's just to give you guys an idea of just a quick preview of what's out there. You might have some cheaper prices. I just look quickly to give an idea. You're going to have some cheap ones on Amazon, which might or might not look like this. That might be $20 to $40. I would stay away for a few reasons. They might be unidirectional. What that means is they will only calculate one way. So you'll know what's coming in. If it's plugged in one way, you'll know what's coming out. If it's plugged in one way, you'll never know both. Also, very often, they won't be able to tell you how much you have in the tank. That's a problem. You'll see, oh, I'm pulling 6 amps, but I got no idea how much I'm putting in, and I got no idea how much I got left. That is basically useless knowledge. So, and often, the shunt that come with them are going to be very low rated. So if you have, let's say for example, everything set up for 100 amps on your house, and your shunt is 50 amp, no good. So those, I wouldn't recommend them at all. The first cheapest one, I didn't even put the brand. I have one of those. It's a different brand. There's like 6 different brands selling Amazon, right? There's like 6 different brands selling the same thing. They work fine. They're the cheapest full-featured option I've seen on the market. So basically, this one will tell your voltage. It will tell your amperage. It works bi-directional. And it will show you your battery capacity, how much you have remaining. Now, you got the Renogy unit, which ironically uses the exact same shunt. I had a customer that had a Renogy. We have the same shunt. Everything is made in China, probably in the same factory. So these two use the exact same shunt. However, the display, I think, is nicer. A bit of a personal preference, but if I was to do it again, I go with the Renogy. Then you get into the Victron, which is more the high-end options. You got what they call the Smart Shunt. No screen. Pros and cons. So this one is Bluetooth only, which means you have to go to your phone to see anything. I don't like it. Some people might like it. Victron also makes some that do have a screen with or without Bluetooth, depending on what you want. Now, price-wise, if you're looking for one, I would probably go with the Renogy. Unless you want Bluetooth, then you got those. These also, actually, let me go back. These will only monitor your house battery. Victron has some that, as an option, can tell you the voltage of your start battery, but it will not monitor the starting battery. Nor do you want to monitor it. You don't care. Use it to start your engine and get topped off by your alternator. So unless you've been cranking it for the last half hour because your engine won't start, at which point, how much is left is the least of your worries. So what you can do is you can have just a simple voltage sensor. What I like to do is you can even get one that has USB because, plug into it. Super cheap. You can get up to maybe $20. Solar, solar, and more solar. So we already covered solar, but we're going to take a look at it in more details. So the panels, you can get them flexible, you can get them rigid. It's basically what works best for your install. One word of warning though, for the flexible, they have to be mounted properly. They are flexible, but if they flap in the wind, they will die a horrible, quick death. Actually, the failure rate on the flexible is much higher than the fixed ones. Because the fixed ones, you really don't have much of a choice to install them properly. They're either installed properly or they fly off. The flexibles, there's all kinds of possibilities to have something that will hold there and flap around and then break. So what is included, and that's where we start getting into more detail that we didn't cover last time. So what you need the panel, obviously. You need the controller, you need wires, and those are special wires. And you need a fuse, because you need a fuse on everything. Basically, when it comes to choosing how big or how much solar you have, is how much you need and how much room you have. I would say if you have the room, use it. If you want to put panels together, you can, but they have to be identical. You cannot mismatch panels on the same controller. You can have different panels on the boat. You could have 3 different panels on your boat as long as they have their own controller. But if you put them together on the same controller, then they need to be matched, they need to be identical. And you can put multiple controllers, no problem. Now, if we put them in parallel, we'll be adding amperage. If we're putting them in series, we'll be adding up voltage. Now, the thing to keep in mind is we can only add up amperage up to a certain point before it becomes a problem. Our wires can only handle so many amps. If we go too high, we might have problems. Also, if we put a lot of big panels in series, well, let's say we have panels that develop 30-some volts. We have 3 of them. We're about 100 volts. So 12 volts won't kill you, at least not from electrocution. But it's not that DC is safer, it's that it's just 12 volts. But if you have 100 DC volts, it's getting in a territory that you could get in trouble. Doesn't mean you can't do it, but you have to be very cognizant of the limitations on each side. If you go with very high voltages, you got to be careful. If you go with very high amperages, you got to make sure your wire can handle it. So for the wiring, it's a special type of wire. They call it solar wire. It is always 10 gauge. If you remember, depending on the distance, the amperage, we have to go with different gauges. In this case, it's always 10 gauge. Not because it's an exception, but because that's kind of what we're stuck with. So that's where it becomes important to make sure we don't go too crazy in the amperage we're asking these wires to carry, because they can only carry so much. An interesting thing here in the example, they're showing black and red, but very often they're going to be black and black, just to make our life interesting. And then what you can do is just add the battery side, not at the battery side, but at the controller side, you'll want to put a shrink wrap, which is red, on the positive so that you know. And we have the connectors right there. I don't know if you guys can see very well, but they basically seal. Those are outdoor rated connectors, which are weatherproof, and they do a pretty good job of keeping the water out of the connectors. Now, the solar wire is only outside the boat. You can use it inside the boat, but you don't need to. It's a special wire which is weatherproof, which is rated against UVs and all that fun stuff. But once the wire goes inside the boat, it doesn't matter. You can use regular wire. Usually what I do is I'll just buy whatever. I don't do a whole lot of solar. So I'll just buy whatever length, approximate length I need from a solar manufacturer, plug it to the panel, run it inside. If I can use the solar wire all the way to the controller, fine. If not, you can just use butt connectors and connect regular 10 gauge wire for the rest of the trip. You don't need to, basically it's 10 gauge wire that's just weather rated. Now if we're going with parallel, we're going to need some kind of splitter, right? Because parallel, we put the plus with the plus, the minus with the minus. So we need one of those or something along those lines. We could combine them directly at the panel, or we might combine them at the controller. Keep in mind, if we go heavy in amperage And it's possible that we might have multiple independent wires coming in because every wire can only handle so much. And we have the example there whether we connect them in parallel or series. So series, the panels are going to be basically piggyback. Actually, I shouldn't do that because these guys are going to frown at me because I'm going too far away from the microphone. So the series, we see they're connected together. So we're only going to have one ground and one positive always. Parallel, you have to use some kind of splitter either at the panel itself or at the controller. Now, when it comes to the solar controllers, we got some features that are basically, I call them user features, which are basically driven by personal preference. You want a screen? Do you have any size constraints? Some are smaller, some are bigger. Do you want Bluetooth connectivity? Those are all options. And the electrical features, those are going to be dictated by your setup. So voltage, amperage. Now the cool thing is that it says right on there. So this one, we see that it can handle a battery bank, which is either 12 or 24 volts, and it can output up to 30 amps. In terms of the solar panels connecting to them, it can handle up to 100 volts max and up to 30 amps. Now, if I have a solar array, because it's probably not one panel, it's probably an array. If I have an array which is 100 volts and gives me 30 amps, is that the right solar controller? Trick question. It's not. It's not at all. Because if you look at what it can handle the input, but it can't output anything close to that. The maximum it can output, and all our battery banks are 12 volts, the maximum it can output at 12 volts is 30 amps. So that's never going to fly. So what these do is that any excess voltage will be transferred into amperage. So that'd be like trying to output 100-something amps. It won't handle it. And if someone wondering, does that mean you can put twice the power out with that one if you have a 24 battery bank, a 24-volt battery bank? It absolutely does. Because this can handle a certain amount of amperage, just like our wires. This can handle a certain amount of amperage. It can handle a ton of voltage. But only so much amperage. So, how much time do we have? Because there's something we covered in the last time.
You're pretty much out of time.
Yeah, all right. So, for those that are interested, that were not there in the first time, that are like, how do you transfer voltage to amperage? We can have a discussion after. So, when it comes to the fuses, again, we've already looked at that. You can get one that is bulkhead mounted. You can get a glass fuse, which will break, which will be a cause of frustration. You can have a blade fuse, or you can use a fuse box. And that fuse box, you're not going to have a fuse box for this, fuse box for that. You can have one fuse box, and you can have everything going to it. Bilge pump, right here. Fridge, right here. Anything which is always on, right here. Same for your solar panels. Everything which is basically not on your panel is going to be right here. They're cheap. They're easy to install. Highly, highly recommend them. And a lot better than having a spaghetti factory of a bunch of glass fuses everywhere. Now, the frequently asked questions for the solar, can you add panels to an existing setup? Absolutely, but they'll need their own controller. If you already have panels and a controller, you want to add more? Well, you're going to need to add panels, you need to add a controller. Which leads us to the second thing. Can you use multiple controllers? Absolutely. No problem. A lot of people do. Can you charge two different banks from the same controller? No, but yes. But no, but yes. So basically, the solar controller itself cannot. But we've seen options that can do that. You can have a battery combiner that will do that. If there's a charge source present, it doesn't have to be your alternator. If there's a charging source present, it will combine them. You could also use a DC to DC charger. There's different options that will allow you to do that. But your solar charge controller itself will only connect and interface and charge one battery bank. And will panels perform at full capacity? Oh, no. No, no, no. Shading, cloud, bird poop. All those things will help decrease your performance of your panel. Now, what we have left is questions, feedback, and a hands-on. So I guess we can leave the hands-on the burner for now and go to the questions if you guys have any. You guys are a quiet crowd. We had like 1,000 questions last time.
Yeah, I'm just wondering, I know there's a huge range, but in your experience, what's a typical cost of a solar setup for maybe 1 to 2 panels, the battery controller, et cetera?
Hold on. So, parts or labor?
Parts, actually, to start.
You're probably looking at about 3. It depends if you go rigid or flexible. If you go flexible panels, and again, those are approximate numbers. And if you go with smaller panels, they're more expensive. Bigger panels, they're cheaper. So if you look at a 100-watt panel, it's probably $150 for a rigid. But if you look at a 400, it's probably about $300. And also, if you go flexible, it's $2 to $3 a panel. Sorry, $2 to $3 a watt for the panels, approximately. There's exceptions. So let's say you go rigid, 2 panels, $150 each, so that would be $300 for the panels. You're probably looking at probably about $200 for the controller, maybe a bit more. Everything keeps going up in price, so assume maybe more, maybe up to 300. So you'd be 600 with a little bit of wiring. So probably 650.
Okay.
650.
Thank you.
And basically to kind of wrap that up, that idea, from a marine perspective, solar panels are not very expensive. In terms of all the things we put on our boats, they're kind of affordable.
Is there a lifespan on the solar panels? Like 10 years, 5 years?
Well, the question depends if they're flexible or
Go flexible.
rigid. Flexible, well, here's the thing. If they're installed perfectly, I think they're rated to last them like 25 years. I'd have to double check. But what's rated and what happens can be different. But I think they're rated 25 years. And again, if you guys remember, because I install solar panels, but I am by no means a great solar expert or guru. But my understanding is they should do about 25. When it comes to flexible, a lot of them don't last as long because a lot of them are not necessarily as well installed. And they're more at risk of kind of flapping in the wind. And even if the solar panel itself doesn't flap in the wind, I mean, if we take a look at the Biminis on a windy day, how many of them are? That's a lot.
But in terms of the life of the photovoltaic cell kind of thing, like
they should last. I'm not worried about the cell itself as much as the physical abuse that the panels have to endure, especially if they're flexible.
Thank you.
But technically speaking, if I remember correctly, I think they're rated for about 25. But I would expect them realistically probably to last a good 10 years. Because I would say most of the things we do on our boats, we probably expect a good maybe 10 years out of them. So I would say yes. I'm confident, or I hope, that my solar panels will give me a good 10 years of service without trouble, at least. Yeah. And what I remember is 25 years, which is the manufacturer's numbers, which, take with a grain of salt. But yeah, that makes a lot of sense. Yes?
Eric, I have 2 questions from the online crowd. One is, where do you source all of the bits and pieces, such as connectors, etc.?
You can get them from Chandlery whenever they have things in stock. You can also get them from Amazon. You can get some stuff fairly cheap from Amazon. I've had some good success, but make sure that what you buy is marine rated, because you're going to get a little bit of everything. Like, for example, these people at home probably won't be able to see us clearly, but the fork connectors that are not captive forks, they're bad. You don't want to use that. But you can get them off Amazon. What's interesting with Amazon is, hear me? So what's interesting with Amazon is you can get kits that have a little bit of everything. So if you're just like a I was gonna say a homeowner, a boat owner, that wants to have not necessarily 200 of everything, but just have a kit with all the basics, you can get some kits off of Amazon, which will be pretty cheap. If not, Channel V has them, although there has been some supply challenges sometimes.
Great, thanks. Another question. Eric, what are the best practices for winter prep and storage for lead acid or flooded AGM batteries that are too big to remove from the boat?
Leave them there. If you have, I guess I should expand on that a bit more.
Please.
So if you have solar, good idea to leave it charged. Your batteries will enjoy being, actually, your battery should be fully charged. The battery is always happy you're charged, especially in the winter. You want your battery to be fully charged. And if you have solar, it's a good idea to leave it plugged in. It's going to keep your battery topped off. And your batteries, if they're fully charged, they will enjoy the cold a bit more. Let's put it that way. Now, it's the absolute reverse if you have lithium. If you have lithium, you can leave them, you can take them off. Some different manufacturers have different recommendations. But you don't want to charge them when it's below zero. It will kill them. Lead acid, you can charge below zero. That's fine. So if you have solar panels in the winter, leave them connected, leave them working. It's going to keep your batteries topped off and happy.
Okay, just a B scenario. What if the solar panel is covered by the tarp? It won't work for sure.
I've never tried a solar panel under a tarp, but I don't think you're going to get much out of it.
No, I guess what I'm saying is, I know people leave their batteries all winter on the boat, not charging.
Yeah, that's fine. That's fine. Make sure they're fully charged. And
Or
if
they
you
give them a
have-
final charge before covering the boat.
Make sure
yeah.
they're topped off in the fall. And some people will come by during the winter to plug it in to give it a charge. Also, you could, technically speaking, you could, again, I don't want to say anything that could get me in trouble. I don't know if it's allowed, but from an electrical perspective, you could potentially leave your boat plugged in. Now, I'm seeing a whole lot of people saying, no, don't tell our members to do that.
No,
They're
can't
not
do it.
allowed to do that. all right, don't do that. You'll get in trouble. From an electrical perspective, that would work. Don't do it.
Thank you. All right, another question from Jason. Eric, if I convert to lithium and have an older inverter charger without a lithium profile, can I remove the AC input to the inverter and buy a lithium charger? All the AC plugs run off the inverter.
Yes, but then you would lose the feature, because basically it's a very good question. So basically inverters, if you have an inverter charger, we think it has two things, but really it has three things. So it has an inverter and it has a charger. So the charger takes 120 volts from shore and charges your battery, and the inverter takes the 12 volts from your battery and gives you 120 volts to use when you're out there off grid. The problem, and it's not necessarily a problem, but you will lose some features, that it also has what we call a transfer switch, specifically an auto transfer switch. So what it does is that if you're connected to shore power, your inverter will allow a pass-through. It's not going to invert. It's just going to allow the shore power to do its thing. If you disconnect the shore power, it's going to see, oh, I'm needed, and it will kick in automatically. So you don't have a switch. You need to choose shore. Sometimes you see those switch generator, shore power, inverter, all that. If you have an inverter charger, you don't need that, because the inverter has it built in. It knows if it has shore power, and if it has shore power, it's not going to invert. If it doesn't have shore power, it will invert. So you will lose that feature, unfortunately. But could it work? Yeah, you could. You could. I would probably just replace the whole thing. And the reason why I'm suggesting to replace the whole thing is the new inverters, they will be what we call a pure sine wave instead of modified sine wave, so it will work better with electronics. Also, they operate at higher efficiency. So my recommendation would still be to replace the whole thing. And not only that, but the newer inverter, if you look at the price of a quality charger, it's not cheap. When you look at the price difference of an inverter charger versus just a charger, the fact that you can still use the auto switch and you got a higher efficiency and it works better with the electronics, you're probably better off replacing the whole unit. My 2 cents.
Okay. Well, thank you very much, Eric. And just a reminder for people watching online that if you'd like to make a donation to the Legacy Fund, that will be open until 10 o'clock tonight. As thanks for Eric, as again last time, we have a card that's good for the online web store. Sorry, there should be a slide here. Yep, the online Regalia web store. So there's a QR code on the back you can use on the store, $40 to any item in the store. And so next week, just as a reminder, we have the Canadian Power and Sail Squadron in to give a talk on what they do in training all of us for, the simple stuff to ocean crossing. So thank you very much and good night.